Okay, okay, so let's go through the next set of exercises on importing data. So we talked about CSV files first off, and how we can bring them in using the read_CSV function. And there's also this read.csv function, but I prefer using this first one because it's a bit quicker, and the output is a tibble. And we talked about how tibbles have a sort of nicer looking display in when we print them to bar, like this, for example. So usually when we print the data frame, we just get the first 10 rows rather than the whole data frame, which we get when we use read.csv. And we also get like a column type summary here, and we don't print all the columns either. So it's a bit easier to manage and a little bit quicker to read in as well. And then we talked a little bit about constructing tables from scratch and converting to tables from non-tables, and yeah, pasting from elsewhere. So the most important part of read_CSV or well, reading in any data is to make sure that you are aware of the different sort of arguments here, that you are using the correct one. So usually you need to open up the file before you read it into R, have an inspection, see whether it has column headers in there, has column names, whether you need to provide the column names yourself, whether you need to skip any lines or read in a subset of the data, that perhaps there's parts that are later on in the data that you need to ignore. So in that case, you would set the n max. And also if there's missing values in the data that you need to incorporate, that perhaps they're not blank, perhaps you've got some stars or some other symbol to represent missing data that you want to bring in. And then we talked about the range of read underscore functions depending on what is being used to separate the values. So CSVs would use a comma. You might use semicolons depending on where you are. So it's more common in, I guess, non-English speaking countries, like French speaking and German speaking countries. You might use colons, and or you might use these pipes or tabs or fixed widths. And then writing data, we would use this write_CSV function. So this first exercise was really practice, getting used to these argument names and effectively reading in just the part of the data frame that you are really concerned about. So let's close these ones down so I don't confuse myself. And then we open up the exercise 3.1. Okay, so let's clear this as well. Apologies. Okay, exercise 3.1. Okay, so the first part was we load the read_CSV function, and then we check out the file. So this file was, I think I got it from the US Census Bureau. And you can see it's quite a nice CSV file in terms of reading it into R. We have the column names on the first row, which is expected. And then if I press the end button, you can see at the bottom, there's nothing here. Sometimes you might get some more information like date downloaded or something that's not part of the data that you're not interested in. So in this case, this data frame is fairly nice. So we can hopefully read it into R without changing any of the defaults. So to do that, we can use, and we want to save it as this D1 in question 2. We can say the file name, and then that's all we need, I think. So then we read it in. It tells us what are the different types of the data that's being read in, and then we can see it's printed out here nicely there. Okay, the next part was on a data set. Where was this? From the UNHCR. So you can see it's a little different here, right? The first 3 rows are not actually part of the data set, right? The column names appear on the fourth row. So in this case, we want to use the skip argument to skip these first 3 rows. And you can also notice here we have a star, which is for a missing value, right? So we need to somehow incorporate that into the read underscore CSV data. And then I press the end key to look at the bottom, and you see, okay, it's fairly nice at the bottom that we don't need to worry about that. So there's two things here, right? One is skipping the data, the first 3 rows, and also setting the NA values to the stars here. So again, we give it the file, and then we can read it in D2, and then we can see we've got, for example, where we had that N star, now we've got the NA, and at the top of the data, we've got the column names. We don't have these blank rows that we would get if we'd missed it. Let's just try it without skip 3, and you can see how it would look. So you can see it looks, the first column name is called extracted from UNHCR. You see there's only 2 columns because we didn't skip the rows. So what it really did was take, let's take a long time. It read this in as the first 2 columns and then interpreted from there, and it got confused. So this is why we need the skip is equal to 3, and then you can see we'll go from 2 columns to the 6 columns. That is actually really the part of the data set that we're interested in. Okay, we can look at the next data frame. Okay, this is TSV, I'm not sure. So it's a tab separated. Okay, maybe I'm not sure. Okay, let's just admit. So this data is from, oh, where is it from? I can't quite remember. This is from Eurostat. And they're tab separated. That means we have these tab spaces in here to separate the columns. So you can see probably when we read this in, we've also got a comma here. So it's very, well, a bit complicated to read in. And I think if I make it wider, yeah, okay, so that looks a bit better. This is a bit more how we should look at it. So one important thing, okay, so on the first row, we've basically got the column names. And also we've got this issue with the colons here, which are representing missing data observations. And then let's go right to the end just to see if there's anything there that's tricky. No, but we do have these letters in here that might be a little bit tricky as well, or missing values. Okay, so when we read this in, the main thing that we note is that we've got the column names on the first row as we want them. But then we've got the colons that are missing values. So we want to use that as to interpret them as missing values. So here we get that in the data. Let's show it here. Okay, so you can see we've got these NAs going on here for the first few years in the first few rows that we've interpreted them as that. So if we didn't do that, so let's just run the data there as is. And then look at the top, we get the colons actually in here. And you can see these columns are now interpreted as character strings. So it sees them as labels rather than numbers, which is what we had in the previous time, where they're double there, the kind of numeric values, right, rather than character strings. This is the importance of using, making sure you identify the symbols that the data supplier is using for the NAs. Okay, so in question 7, another bit of data. I think I got this from the Norwegian Statistical Agency. So this is data for different parts of Norway on how many people live in different household sizes. So you can see this data is not easy to read in. You have these blank rows. It's also not comma separated. It's using semicolons. And you can see the kind of, well, the first row is not really anything of use in terms of a proper column name. But the actual column names is on the second row. So we probably want to skip this first row. Otherwise, our column names are going to be called size of household, size of household, size of household. So it's not really telling us too much about what's going on. And then let's see at the bottom, is there anything mysterious, a surprise? Let's go down. Okay, so that all looks fine at the bottom. Okay, so then let's read the data into R using the, we're going to use read dlim, or we could use read CSV2, either of them would work. In this case, with read dlim, we're going to say we're going to use the semicolon, which is what is being used to separate the data into different columns. And we're going to skip the first row because of the sort of ambiguity in the column names. So you can see we've read them in, and you can see we get this warning message when we do it. It's read the data in, but we get the warning message that there was no column name in the first column name and the seventh column. So it's filled it in, it's called it X1 and X7. So you can see here, it's read in the data for us, okay. But you can sort of see how it did that. Let's go to the end. So you can see there's this missing column here, but you see before the first semicolon here, there's no value. So for this first, but in the later on in the data, before the first semicolon, there is a value. So that's why it's got a bit confused. So it's filled them in. In any case, we learn later on how to deal with like these missing rows, how to drop them. We'll learn how to rename the column names. So this is probably as good as we need, so long we've got the data in and we've identified the missing rows. And we've not got parts of the data that we're not interested in. Okay, this I think final part of data frame is from the German Statistical Agency. And again, this is more complicated. They're using semicolons again to separate the columns. And you can see this first row, it's not really part of the data. The second row is part of, well, it's again describing the data set. And then when we get down to the fifth and sixth row, these two rows are really giving us a description of the data. So they are telling us in the first column we have got Germans. Well, in the first three columns we've got Germans, in the next three columns we've got foreigners, and the next three columns we've got totals. And each of them we got the males, females, and totals. So what they've done essentially is spread the column names over multiple rows, which makes it a lot more, well, let's say it's not easy to read into any sort of statistical software like that, so it's not so practical. And right at the bottom here, you see on those last rows, they've also added in a nice surprise of having some more like copyright information and details about the data set. It's not part of the data set itself. So again, this is something that we don't really want to read into R. Otherwise, it's, we don't want this sort of data included in any plot or regression model that we want, something that we want to ignore. So we use the nmax argument for that. Okay, so let's go back. Okay, let's close this down. Let's go back to the code on how to read this in. So what I did is create the column names in a separate R object here. So these are going to be the column names. Because they spread them over multiple rows and it's so complicated, we can define them and then read them in ourselves. So this is what I've done here. So the column names are going to be equal to this vector. And we also skip the first 6 rows. So we're going to bring in the data without any column names and give it manually to them here. And we're going to skip the first 6 rows. And then after row 1472, we're not going to read in any more data. So where do we get that 1472 from? So where was it? Which data set was it? It was this one, wasn't it? So you see here, the number is 1478. But then remember the top, we skip the first 6 rows because we don't want to bring in any of the column names. We bring them ourselves. So it's this 1478 minus 6 to get the 1472 to read them in. So again, there's a bit of trial and error. When you read it in, you need to check the data that it's read in, that everything's looking, the type of the columns are behaving as you expect. So here it's picked it up that they are a date, but I guess if I didn't do that nmax, and you see we get these problems, we get these RMS warnings, so things haven't worked correctly, and that's because it's brought in these messages as well below here. So it was expecting to read in dates, but it got in some labels, some character strings in there, so it wasn't too happy. So this is really where it might take a few times trial and error to get this working. Okay, and the last bit was just practice writing data frame. So we just save this D2 data frame. This is where we're going to save it in the data how do we say, the data folder, and then this is going to be the name that we're going to save it as the UNHCR. Okay, so that was exercise 1 in this set of slides, exercise 3.1. Just practice getting familiar with the different options when you read in data and different things that you need to consider. Okay, this next part was talking about just how to sort of get used to and explore the data frame that's being read in, and looking at the different functions that work on that, looking at the view in RStudio. And then the part here was the next section was talking about factors, which this sort of way of representing categorical data with a level attribute telling us about the order of the categories that exist. If there is an ordering, then we use factors. So here we talked about how we can change the factor values. We might want to recode them, or we might want to change the order of the factors that they appear on. For example, we might want to order them as they appear in the data. We might want to reverse the order. So this is useful when you're building a model or you're building a plot. Perhaps you want to change the order that the countries are appearing in the plot here. And here, the whole time we're using different parts of the full-cap, different functions in the full-caps package to do that. And okay, so yeah, remember when we're using these factor operations, we're not actually changing the label, well, unless we're explicitly doing this. We're just changing the order of the labels that exist. So there's this kind of hidden characteristic on how they're ordered. And then this is for more general conversion of the different types of data. So here we're converting, for example, some of the character vectors, turning a numeric value into a character string. Okay, so this exercise 3.2 was really working with playing around with these different functions for data frames, and also working with the full-cats package to get practice working with factors, which, like I said, are important when we come to running regression models in R, or if you want to control the order of categories in a plot. So we run the exercise 3.2 prelim. Let me clear out everything so we start afresh. When we run this, we essentially read in the data that we had in from the previous exercise. So remember, D1 was this data from California or from the US, I think, on the different population sizes, median age, and the male and female population household sizes in different zip codes. And if we just want to find the dimensions of that data frame, we can use the dim function. If we want to find a summary of each column, we can use the summary function. And here will give us for example, the range of the populations and the mean and medians. We want to look at just the top, the first three columns. First three rows, we can use the head function at the top of the data frame. We want the column names, we can use the col names function. Okay, if we want to convert a variable to a factor, then we can use the factor function. So here we're going to use the D5 data, which was this German data. Okay, and so we have this D5 name is the different regions. So you can see this is there's over 1,400 rows in the data frame, and you can see we're repeating the different German regions here. So if we want to convert that to a factor, let's just double check D5. You see by default it's a character string. So if we want to change it to a factor, then we can use the factor function and override it using the assignment. And then we can use the levels function to see the order of the categories that it's created when we made a factor. So by default, when we do this, when we use factor, the levels are going to be the order of the levels are going to go in alphabetical order. But it might be that we want to change that. So this is what really the next part of the questions is. It's perhaps you want to reverse the order, for example. In this case, we could use the factor reverse, FCTREV. And then when we see the levels, they're now in reverse alphabetical order. Okay. Or it might be that we want to bring a specific value to be the first in the order. So in that case, we would use factor relevel to do this. And again, overwrite the function, the DF5 name column with the new version where the factor with the first level is set to Berlin. Okay, so then when we look at the levels, you can see it's in reverse alphabetical order, except the first one is now Berlin. As before, Berlin was what, the 14th. This time it's the first because we use factor relevel. Okay, so hopefully that gives you a good idea, a bit of practice with using these different summary functions. How do you say? Yeah, functions for data frames and the full-cats package for working with factors. Okay, so the last part of this set of slides was for working with different types of data other than CSV files or delimitated files that we talked about so far. So if you want to read Excel packages into R, then we can use this read Excel package. This is probably the best way to do it. There are different options, but I recommend this package, and which has this read Excel function, which works in a very similar fashion as the read underscore CSV that we just showed with. So, for example, it has the nmax, it has the skip arguments, it has the NA arguments, that we talked about before. So one other argument that we didn't talk about before, but is available both in the readr functions and the read Excel, is this guess max argument. And so this is useful for it's useful to know what it does. Is for when we read in data that can be a little bit more complicated. So by default, when when read underscore CSV or read underscore Excel is reading in the data, it's using the first 1,000 observations to guess what the type of data is. If it's a date, if it's a character string, if it's a numeric value, right? It's guessing that based only on the first 1,000 values. And it does that because it's quick. So it means it's just going to assume that what's in the first 1,000 rows is going to be the same as in the rest of the data set. But you might want to change this because sometimes you might get a warning message that perhaps the data type is a mix of types. And so it might incorrectly read the types in, and it would give you this message if you want to change this. Okay. So this is just reading in Excel data, and then this is for writing Excel data. So it's not as easy as writing a CSV file. You need to use this open XLSX package where you create this temporary object on your computer, which is like an empty Excel spreadsheet, where then you can add spreadsheets to it and add data to the new spreadsheets that you add, and then you can save the Excel workbook from a temporary file in your temporary directory to a specific Excel file on your computer. And then for reading in other data types like SPSS, Stata, and SAS files, there's the Haven package in R, which again works very similarly to the readr functions for read underscore CSV or read underscore Excel functions. So again, here we're reading in with some SPSS data, and here we're looking, the data comes in a bit more complicated form where we have the code and the label, and how we talk about here how we can convert this sort of labeled data to a sort of continuous data frame to a factor. Here we convert the labeled ages. So we want to get rid of these labels and just use the values, for example. So here we can zap the labels, and it will give us just the numeric values here. And then, this was reading in Stata files. Again, we get these labeled data that we might want to get rid of if we are going on to plot the data, perhaps, or work with a regression model. And here's reading in some SAS data. And this was just a summary of the read and the write functions for the different types of files. Okay, so this final exercise in this section was practice with these different data types and with creating an Excel file. So here we're going to read in this Excel data frame. Let's open it up before we read it in. And where is it? Data SAP. Okay. I think I need to do it in here. Data. This one. Okay. I think this isn't one that we haven't looked at so far. So you see this data frame. This data frame is from the UK, England and Wales Office of National Statistics. See this first sheet. It's not actually got any data in it. It's all kind of legal and terms and conditions, notes, and a bit more details about the rest of the spreadsheet, right? So when we use read_Excel to bring it into R, then we want to ignore this first sheet, right? We want to perhaps take the second sheet. And when we take this second sheet, again, just like in the CSVs, you might want to skip these first 3 rows. There's actually, these don't actually contain the data, the core of the data frame, right? These are more titles than they are anything to do with the column names or the column rows. And at the end, it seems fine. We don't have anything too messy there. Okay, so when we read this data in, we give it the path of the data, just as we had before, and then we can put the sheet. So we could either write sheet is equal to 2, or sheet is equal to, if it's the male data frame, what have we got there? Then it would be the third data frame. So we can put sheet is equal to 3, and then we want to skip the first 2 rows. So with sheet, we can give it either the number or the actual name of the sheet as it is in the spreadsheet. So when we read this in, and we can see we've got the D6 here, and it seems to have read in everything okay. It just says on this third column, it's created a new name, but there's not a name there. So let's go back here. And that's this part here, right? You see the first, second, and then the third, there's no name in that cell. So it's created one for us. So it's just printed a warning there for us, or a message. So let's just show another example, right, where we give it sheet is equal to, let's say it's sheet 2. Yeah. Then read it in again. Okay, and then we can see that's another way to do it rather than write out the full name that we had here. Okay, and question 2 was to, again, practice reading in another Excel file, this time from the UN. So which one do we read in? Population by age. So let's see this one, UNHCR, population by age. Which one is it? F701. Okay. So these UN spreadsheets are a little bit more complicated than the previous one. You can see the first, 16 rows. We don't really have, we have more kind of detail on the data frame, but not actually the actual data frame. So we want to skip those rows, and then we can see the actual column names come in on the 17th column. So when we write the R code to import that, we can again set skip is equal to 16 and read in the data, and then you can see we've got it in a fairly nice format in R then by getting rid of the first 16 rows. Okay, and the next part was just practice reading in this Stata file. I don't have Stata on this computer, so I can't open it, but we can read it in, and you can see it works quite nicely. It just takes a bit of time. Okay, and then let's see this data frame, what has over 1.2 million rows in there and 10 columns, but it read in fairly quickly, at least on this laptop. And if we want to look at the ages, for example, the labels for the ages, then we can use the print labels function to do this. If we want to remove these labels from the age column, then we can use the zap labels function. So we're going to have D8 age, which has this lots and lots of values in there, a million values. and these labels, but if we want to get rid of the labels, and then we can run this here, run the zap labels, and then you can see on the age column, it's now a numeric value rather than a numeric and labeled value, which we had before. Here we go. So remember here we had the sort of name and the label before. Okay, if we want to convert all the other labeled columns to factors, then we can use the as_factor function. So when we run this, you see what we had before for Panama, where we had the country code, and in the year we had the year code and the year name, which is kind of a bit pointless. So this is kind of why we might want to use this as factor to drop the labels and just use whatever the label was and use it as a factor in this case. And the same for nativity here. This has gone from what was a code from 1, 2, or 3, whether you're native or foreign. Now it's gone to the actual label itself. Okay, then this last part, question 7, was I think I gave a sort of template of the code, so it wasn't filling in all of this. It was creating an Excel worksheet. So again, when we do this, we want to create a workbook using the create workbook function. And then you can see what we have here is a link to a temporary file on your computer. We can start to add some worksheets. So it's an empty Excel file, essentially, at the moment. And when we run these 2 lines where we create these 2 worksheets, the first sheet is going to be in this workbook, WB0 that we've created. The first sheet is going to be for the England and Wales data, and the second sheet is going to be for the UN data. So this has just created 2 empty sheets inside this empty workbook, and then we can start to populate it with the write data function. So into the sheet 1 of the workbook, we can add the D6 data. Remember the D6 was this England and Wales data, and then D7 was the UN data. So we can run these 2. And this is all happening in the background in R. We're not really seeing anything update at all. Like I said, this WB0 is like a temporary file on your computer, so it's not visually easy to understand what's going on. Only until you save the workbook can you really inspect the output that's gone on. So in this part, in these next 2 parts, we first freeze the first row in the first sheet. So we use freeze pane to do that. So this is in sheet 1, we're going to freeze the first row, and then we're going to add a filter into the second sheet on the first row. So we can use this add filter function. Ooh, I'm not sure if that would have worked. Maybe, I think that's because we had that empty column name. So it's just a warning, so perhaps it's okay. Okay, so like I said, this is all happening in the background. And if we really actually want to save it, then we can use the save workbook, but it says it already exists. So let's put overwrite equal to true. I think that's from where I did it the last time. Okay, and then we can open it, and we should wait a second, and there we go. So it created it fine. So remember, we first added these sheet names and they were empty. And now we've saved in the D6 and the D7 objects. And you can see in this D6 in the first sheet, we freeze the rows. So that means when we page down the column names here in row 1, they're kind of frozen. So they're not filtering. And in the second sheet, we've got these filters already added in there. So for perhaps we want to get a different country. Let's say France. Oh, I'm putting the wrong column. Country would be here. Yeah, okay. Let's get Algeria. So then we could get the data there. So that's the nice advantage of that is it's you can sort of programmatically create these Excel sheets from R once you've sort of done any analysis or data manipulations, and save them all for yourself. So Let's go back to the slides. I think, yeah, that was the last sheet, last slide. So perhaps we finish a little earlier and take a 10-minute break until till 15 minutes for 10 minutes until 10 to the hour, because I think the next section is yeah, more exercises than this section. Okay, so let's see each other in 10 minutes to go through the final set of slides and their exercises.